In today's battlefields, the first units to move aren't soldiers, they're machines. The US Army is integrating robotic mules and autonomous scout vehicles into its frontline brigades. In China, armed quadrupeds and AI-driven reconnaissance bots now train beside infantry. In India, defense labs are developing rugged, low-cost robots for high-altitude and border operations. And in Ukraine, remote-controlled gun platforms and bomb-carrying drones are part of daily warfare. Each of these machines represents a shift in military thinking, away from manpower and toward machine power. They don't replace the soldier outright, but they're changing what a soldier is expected to do. For the first time in history, machines aren't just tools of war. The evolution is happening fast. From remote-controlled bomb squads to self-guided drones and humanoid prototypes, modern warfare is being rewritten by code, sensors, and silicon. The result is a new kind of battlefield, one where the side with the smartest machines, not the bravest troops, could decide the outcome. This is how the robot age of war began, and how it's redefining the future of combat, command, and control. Every revolution in warfare begins with necessity. In the early 2000s, two long wars forced militaries to confront the limits of human endurance. In Iraq and Afghanistan, improvised explosive devices, or IEDs, became the deadliest weapon of insurgents. Each dirt road was a potential ambush. Clearing them was slow, lethal work. So engineers built machines to take the risk instead. The first generation of combat robots wasn't autonomous. It was remote-controlled. Simple, rugged, and expendable. iRobot's PackBot and Foster Miller's Talon became the backbone of bomb disposal teams. Soldiers operated them through consoles. Their cameras and arms crawled ahead to disarm explosives. By 2008, over 12,000 of these robots had been deployed across the US and NATO forces. Each one represented a small victory against the randomness of death. If the robot exploded, the human didn't. At the same time, above the skies, another robotic revolution was taking shape. Unmanned aerial vehicles, Predator and Reaper, proved that war could be fought remotely from thousands of kilometers away. Pilots in Nevada could strike in Kandahar with the click of a mouse. These early systems still relied on humans, but they revealed something profound. Autonomy didn't need to mean total independence. It could mean speed, precision, and reduced exposure. As algorithms advanced, the distinction between tail-operated and autonomous blurred. Robots began navigating on their own, recognizing terrain, identifying objects, even planning routes. Software started doing what once required a crew of humans, and out of these lessons, the concept of the autonomous warrior was born. A machine capable not only of following commands, but of interpreting intent. By the 2010s, both the US and its rivals were experimenting with manned-unmanned teaming. Attack helicopters shared sensor feeds with drones. Tanks received targeting data from small ground robots ahead. The US Army's Future Vertical Lift program envisioned crews commanding entire fleets of robotic wingmen. Meanwhile, Russia's Uran-9 and China's Sharp Claw prototypes hinted at a new kind of warfare, one where distance and data mattered more than courage. The question was no longer if robots could fight. It was how much fighting humans were willing to give up. Fast forward to today, and the mechanical soldier no longer rolls on tracks. It walks. Quadruped robots, robot dogs, are among the most recognizable faces of the new ground warfare. Their presence is almost eerie. Machines that move not like machines, but like things, flexing, bounding, recovering balance when kicked. Boston Dynamics' Spot was the first to make the world look twice. Designed initially for industrial inspection, it quickly caught the Pentagon's attention. Weighing about 30 kilograms, Spot can carry sensors, cameras, or communication gear, climb stairs, and navigate rubble. The US military tested it for base patrols, tunnel mapping, and nuclear inspection. It became, in essence, the perfect scout. Quiet, tireless, fearless. Then came Ghost Robotics Vision 60, a heavier military-grade evolution. Ruggedized, waterproofed, and modular, the Vision 60 was designed for perimeter security and reconnaissance. At Tyndall Air Force Base, Florida, Vision 60s began patrolling autonomously, reporting intrusions, scanning with thermal sensors, even using AI to recognize threats. In 2021, an experimental version appeared at a defense expo carrying a rifle system, sparking global controversy. Ghost Robotics insisted it remained semi-autonomous. Critics saw the first steps toward killer robots. Either way, the symbolism was clear. The era of unarmed scouts was ending. China quickly answered. Its quadrupeds, sleek, modular, domestically produced, now appear in People's Liberation Army drills. Footage shows them disembarking from troop carriers, advancing in formation with infantry, sometimes armed with small automatic weapons. Integrated LiDAR, domestic AI chips, and swarm communications make them cheap and adaptive. Where the US pursues precision, China pursues mass. India joined the race with its own approach: affordability. Startups backed by the Defense Research and Development Organization unveiled low-cost quadrupeds built for mountain logistics. Robots that carry ammunition and rations to high-altitude posts where humans struggle for oxygen. Companies like ArrowArc prototyped dogbots for under a tenth of Western prices. Simpler electronics, longer endurance, easier repairs. But with each improvement, a question grows louder. When a robot can see, move, and decide faster than a soldier, who really leads the fight? It was inevitable. If a robot can carry a sensor, it can carry a weapon. South Korea took the first open step with the SGR-A1 sentry gun, installed along the demilitarized zone. Equipped with cameras, sensors, and AI recognition, it can warn intruders, identify uniforms, and, if authorized, open fire automatically. Officially, a human remains in the loop, but the technology allows full autonomy. Russia followed with its Uran-9 unmanned combat vehicle, a tracked robot carrying autocannons, rockets, and anti-tank missiles. In Syria, the Uran-9